Hi, welcome to our video on rivers. If you will, go ahead and copy down this vocabulary. All right. Here is a riddle for you as your bell ringer. What runs but never walks, has a mouth but never talks, has a bed but never sleeps, has a head but never weeps? The answer, if you will, write that down please. Drum roll, is a river. That's what we're going to be studying today. Let's get started. So rivers and streams are areas where the water table meets the Earth's surface. We talked in depth about the water table. That is the line or height at which the zone of saturation is closest to the surface. In this case, it meets the Earth's surface and actually goes above it. So that means that the ground underneath a river or a stream is completely saturated with water for whatever reason. The headwaters is the beginning of a river. It's usually found in the mountains. Runoff from mountains flows into valleys, and valleys eventually will become saturated, meaning the water table has reached the surface. And then we have a river, and they flow to the lowest point. So rivers never will flow against gravity. They're always passive. They go from the highest point of elevation to the lowest point. That's why they're usually found in mountains. We have these things called tributaries. They're actually smaller rivers that feed into bigger rivers. They're more found in mountains than in flat land, right? So if you look at the Amazon River real quick right here in South America, you can see that big purple line is the Amazon River, but all of the little blue lines are tributaries, which means that they feed into the Amazon River, making it larger, increasing the volume of water. The mouth of the river is where the river flows into a larger body of water. This could be another river if it was a tributary, a lake, or even the ocean. But eventually the river is going to end somewhere. Watersheds, river basins, or drainage basins, those are all three words for the same thing. They're a region of land that contributes water to a stream or river. So if you look at the Cape Fear River, which is the one that is right down the street from us, all of that area in what you might consider a green color is going to drain into the Cape Fear River, all of the water there, if it is not already absorbed by the ground. A divide is the boundary between the streams of adjacent watersheds. Typically, they're going to be like mountains. So if you can see right here, here's an example. The divide in this case is the mountain. If the water lands on this side, it's going to flow into this river basin. If it lands on the other side, it's going to flow into another river basin. Okay, so divide is the boundary. A watershed is the area that contributes water to a stream or river. So in this case, right here in between the Yadkin Pd and the Cape Fear River, we have a boundary. We have a boundary or divide between the Lumberton or the Lumber River and the Cape Fear River, and so forth. A channel is the course the water in a river or a stream flows through. So a channel is the actual flow of the river. This one has lots of meanders or bends. We're going to talk about that in just a second. A gradient is the slope or steepness of a channel. It's usually expressed as the vertical drop of a stream over a certain distance or change in elevation. So if you were looking at perhaps a mountain, it might have a very steep gradient. So the head of the river might be very, very high in elevation, while the mouth or whatever point of the river you choose to measure would have a lower elevation, and it's depending on how diagonal or vertical the line is. So if it's more vertical, it's very, very steep. If it is more horizontal, it's going to be thought of as a gentler gradient. Okay, So we're talking the river overall. So this isn't like the bank of the river, it's the river over time. So if this was the head of the river or the very beginning in the mountain, and this was the mouth, say it flowed into the ocean. So the closer you get to the mouth of the river, typically the more gentle the river is going to be as far as gradient goes. Discharge of a stream. So the volume of water flowing past a certain point in a given unit of time. I know that's not a very specific definition, but it just kind of depends on what you measure and where you measure. So it's usually measured in cubic meters per second. So how many cubic meters of water flow past a certain point per second? Okay. So if it has a very large discharge, that means it is flowing really quickly. If it has a smaller discharge, it is flowing more gently. If you'll see here, the Amazon, one of the biggest rivers, the top river, I guess, in the world, has a discharge of about 175,000 cubic feet per second. Means it's flowing super fast. You would not want to get caught up in the Amazon. The Congo is much, much smaller. It's about 39,000 cubic feet per second. If you go down to something we might know, the Missouri or the Mississippi River is only flowing at 17,270 270 cubic feet per second. So the Mississippi River flows much more gently than the Amazon River, or we would say it has a much smaller discharge. Stream load is the solid matter carried by a river or stream. Erosion removes minerals from the stream banks, adding this material to the regular flow of the water. If you will think for a second here, there's a relationship between stream velocity and the capability of a stream to carry rocks or sediments, right? So the solid matter, rocks or sediments, it could be plants as well, possibly animals. But the higher the stream velocity or the faster the river is going, the more able it is to carry more, right? So if you're thinking for a second, if you have, say you were hit, that's not a good example. Say I was running super duper fast and I ran into one of you. I am more likely with my momentum to be able to move you farther if I'm moving faster. If I just bump into you, like I take one step and bump, you're not going to move as far. It's not going to have as much of an effect as if I was running at you and hit you, right? Same thing with the river. The faster the river is flowing, the more able it is to pick up sediments along the bottom. Okay, so you're going to switch the page. You have another set of notes. We're going to go through them real quickly. It's about stream erosion and deposition and how we can use these two to understand more about rivers. That'll be a next lecture though.